Functions, differentiation and integration. Day 1, properties of exponents. All right, this is a review basically of a lot of pre-calc and algebra 2 topics. All right, first off, this is review the fact that natural log and exponents are opposites. Exponent with a base e. So in other words, y equals e to the x is the inverse of y equals natural log of x, or y equals e to the x if and only if x equals the natural log of y. And they're opposites. Okay? So because they're opposites, we can use that fact to solve exponential equations. Right? To solve an exponential equation, we got 7 equals e to the x plus 1. What we'll do is we'll do the opposite of the exponent, which is the natural log. So we'll take the natural log of both sides. Natural log of 7 equals natural log of e to the x plus 1. Apply exponent properties. That'll come out front, or apply log properties, sorry. Natural log of 7 equals x plus 1 times the natural log of e. Natural log of e is 1. So the natural log of 7 equals x plus 1. Subtract 1, x equals the natural log of 7 minus 1. Take a look at that. Natural log of 7 minus 1 is 0.9459. All right. We can also solve a natural log using the fact that it's the opposite of an exponent. So we'll take e to both sides. E to the natural log of 2x minus 3 equals e to the 5th. Here e and natural log are opposites, so they'll cancel. 2x minus 3 equals e to the 5th. Solve by add 3, divide by 2. X equals e to the 5th plus 3 divided by 2, which is approximately e to the 5th plus 3 divided by 2, 75.7065. Okay, and some exponential properties that become very important. E to the a, e to the b, we can simplify that to e to the a plus b. Likewise, we can separate e to the a plus b to e to the a, e to the b. So multiplication of exponents can be simplified to an addition. We simplify it to addition inside the exponent. And a division of exponents, simplify it to subtraction in the exponent. All right. Some properties you need to know. You need to know the domain of e to the x is all real numbers. If you look at the graph, the domain, every x value will work. But for answers, we only get positive values. Our range is 0 to infinity. Never actually gets to 0. The function is continuous, increasing in 1 to 1, so therefore it has the inverse, which we just discussed is the natural log. And the limit, as we approach negative infinity, is 0. And the limit as we approach infinity is infinity. So it increases without bounds to the right, but approaches 0 to the left. It's always concave up. So we know our first derivative is always positive. Our second derivative is always positive. Right? Solve for x. On this one, anytime you got a fraction, it's not a bad idea to just multiply both sides by the denominator and get rid of it. So we got 5,000 equals 2 times 1 plus e to the 2x. Right, just make sure you don't divide or multiply by 0. That gets rid of it. Divide by 2, we get 2,500 equals 1 plus e to the 2x. We'll subtract 1, 24.99 equals e to the 2x. And then we got a log. We can go the natural log of 24.99 equals 2x. So x equals the natural log of 24.99 over 2. Or you could say equals 1/2 times the natural log of 24.99. Or you could say the natural log of the square root of 24.99. Just if this is a multiple choice test, those are a couple ways you may see the answer. Or if it's a calculator-based multiple choice test, natural log of the square root 24.99 is a 3.9118. Okay, next problem. Natural log of the square root of x plus 2 equals 1. A couple ways you can do this. I always like to expand my logs if possible. All right, and the only expansion you're going to want to do is for the exponent. So I like to get that exponent out of there. You got 1/2 natural log of x plus 2 equals 1. We'll multiply both sides by 2 to get rid of the 1/2. Natural log of x plus 2 equals 2. So x plus 2 equals e squared. So x equals e squared minus 2. E squared minus 2 is 5.389. All right, so in review, the exponent rules. All right, can't really use them here. They'll become important later on. You want, if you're multiplying two exponents with the same base, you can simplify that by adding the powers. You got one exponent. If you're dividing two exponents with the same base, you can simplify that by subtracting the powers, and you got one exponent. Become very important when we do separation of variables.